And off we go. All right, Chapter 1 preview. Getting us ready for the test here. Again, that's a big chunk of your grade draft to pass. So if some of you have been kind of struggling with some things and you've been looking for a way to kind of get that grade up in a hurry, this is going to be your opportunity. So over the next couple of days, really focus in, ask some good questions, do some things like that, and we should have you ready to go so you can kick butt on that test come Wednesday and Thursday. Thank you. So that's what we're up to here. Okay, numero uno. Place an X in each box that correctly categorizes the number. Now, it could be several of the particular. Okay, so let's see. An integer. Anybody remember what an integer is, or like an example of one? Oh boy. Integer. Are integers like fractions? Okay. Basically, we're looking at whole numbers like 2 or 3 or -1 or 5. Something, though, that comes out nice and clean. So, for instance, if I take the square root of 20, and I say, okay, I'm going to punch this up on here. Square root of 20. That's not coming out clean for me. Okay, so it's not an integer. Definitely not an integer. Square root, if you hit second, let me move this up a little bit. If you hit second and then the x squared button about halfway down, that'll get you your square root button. Then we'll plug the number in. Irrational, if we remember back a little bit, and I'll try to squeeze both of these in. Irrational is going to be square roots that are not perfect. For instance, if I were to plug in like the square root of 9, that comes out nice. It comes out to 3. Okay? That wouldn't be irrational. But this one, since it comes out with this big nasty decimal, this one is irrational. Okay? So, what we're going to do, okay, if something is irrational, it can't be rational as well. So, since we mark irrational, which is basically just square roots that aren't perfect, we can't mark the same one and mark it rational. That wouldn't make sense. So, real basically is any number that I can punch into the calculator. Is any number I can punch into the calculator and have it come back with an answer. Well, since when I did the square root of 20, it gave me an answer, it's real. So, okay, rational is everything but non-perfect radicals. So, for instance, if I get a square root and I punch it in and I get a big funky decimal, that's irrational. Okay? Anything else, fractions, decimals, whole numbers, doesn't matter. Everything else goes in the rational. Okay? And then anything that I can punch into my calculator and it comes out a regular number is real, even if it's a decimal or anything. Yes, unless I punch it in and it says like error. That doesn't happen very often though. So most things that we deal with are going to be real. But yes, that's a very good way of putting it. Now sometimes you'll get something that doesn't look like something that maybe it is. For instance, you look at 8/4 and you're like, hey, I've got a fraction here. But really, correct. 8/4 is really just 2.
So it'd be everything but irrational.
I agree.
Yeah.
I totally and completely agree. Nicely done. Okay, so, Tyler. Focus. Okay. It would be integer. Okay. It would be rational because it's not a radical. And it would be real. So we can. Okay. If you do anything, if you have a square root, you remember before when we had that list when we were doing the square root, and if it was a number that was in the list, they came out nice, okay? Those are all rational. Okay, but you don't have to know it. You can always punch them into the calculator. Because if I take the square root that they give me, and I punch it into the calculator, and it comes out nice, it's rational. If I punch the square root in the calculator and it comes out all nasty, then it's irrational. Okay? But that's very good. I'm glad. I appreciate you guys when you're willing to talk to me on this stuff and ask questions and make sure that we got this. Okay? So that's going to be the first part, kind of going through some of those types of things. Now, when we get to 3, same idea, except now it's just 1, and we're saying which of the following numbers is irrational. So there's only going to be 1. Well, irrational. Okay, remember, irrational has to be something with a square root, so we know it's not one of those two. Which one of those two, if you punch in the calculator, doesn't come out nice? B. Because if I punch A into the calculator, right, the square root of 9 is 3, which is definitely not irrational. So that's how that one works. But again, kind of give yourself that as a hint. We're just getting some of this stuff under review, so when you're doing it on the test, it's easier. Hey, which of the following rational numbers is an integer? It depends on what they're at. If it's an integer, it doesn't. Integers are both positive and negative. So this one would end up being B because it's the only one that's whole. It doesn't have a decimal or a fraction or something with it. Okay? Integers are just numbers that aren't fractions or decimals. Yes. A whole number, except it can be positive or negative. Bump this up a little. I still want that chart there as long as I can keep it. Okay. Which of the following best classifies 7 over 4? Okay, so let's see. We've got rational and real, irrational and real, or integer, rational, and real. Okay, let's think about this for a minute. Is this rational or irrational? It's rational, because remember, okay, hang on. Rational, irrational is only when it's a square root that gives me a funky decimal. This isn't a square root, so I know it's not irrational, so it's not going to be B. What's the difference between A and C here? C has integer. If I do 7 divided by 4, does that come out nice? No. So since it doesn't, that wipes out this one. We have to have A. So sometimes I'm going to get to the answer just by going ahead and trying everything out until I find the one that just happens to work. Oh, here comes our arch nemesis, the radicals. All right. I will, when you're taking the test, I will have the chart up on the board or the screen or somewhere, because I know some of you are having some issues with those. Remember, when you're breaking down the radical, one of the two numbers you use to break it down has to be a perfect square. So, two numbers that multiply to 12, one of them has to be in this list of mine up here, in here. What multiplies to 12? Excuse me. 4 and 3. So I'm going to break these up into 4 and 3. They both get square roots, and I'm not forgetting about the 2. I'm just not using it yet. The 4 is perfect. It's in my list. It gets out of radical jail. Gets its new identity, 2. Do I see 3 anywhere in the list that I've got up there with the radicals? No. It's got to stay underneath. And then that 2 that was there before gets to come back into play. 2 times 2 is 4 times the square root of 3. Okay? There's lots of little things there that can get you, because notice if I look at D, D's got the same numbers, but they just switched them around. The 3 was left out. So you've got to be careful. But you've got to find that one number in the list that will divide into 12. You've got to sit there on your calculator and try them all out. So that's one of the ways that we can do that. 7, 8, 9 is going to be the same thing. 7, I need 2 numbers that go into 40. One of them has to be on that list. Okay, I heard 4 and 10. Again, the one that's perfect, look at the list, the number below it's 2. Out of radical jail it goes. 10, still being irrational, has to stay under. And it has to be in that order. Okay, I can't have 10 square root of 2. They're not the same thing. But keep finding that first number from your list. So 18, what's that going to look like? 9 and 2. Because if I do 6 and 3, remember, one of my 2 numbers has to be here. Has to be. I don't have a choice. And right, the 9 simplifies to 3. Square root of 9 is 3. Square root of 2. Okay. Only break down the radicals. 45, talk to me. Okay. Okay, we're going to ignore this for a minute. I thought I heard it. Okay, 9 and 5. We're ignoring that negative out there for just a moment. Okay, right, square root of 9 is 3. Square root of 5, but that negative 2 is lurking out there. So here's what we're going to do. Now that these 2 guys are both out of radical jail, I can multiply them together. So negative 2 times 3 is negative 6 square root of 5. Okay. Our idea here is that I do the radical part first, then I go back and do the multiplying stuff after that. Okay? But we always want it to be in that order. And like it says in the directions, there's no decimaling on these. Because that's not helping us to break stuff down in a way that we're trying to. So that basically, I got through, what, about first 2 or 3 days of school there, I think, on the first one. So if we move up a little, okay, solve when a equals 4, b equals negative 2, and circle the correct answer. So all I'm doing here is I'm going to take whatever value that variable has. So a has a value of 4. And I want to use parentheses when I'm substituting in, because it's tempting sometimes then. If that had been positive 2, some of you might look at that like 32. And I can understand how that could be, but that's not how this works. But now comes the fun part. I got to do one of 2 things. Either I've got to follow order of operations, or move this over a little. Try to get it where we can see it a little bit better. I can type in exactly what I see on the calculator and hit enter and get there. But again, you've got to be really careful. If I forget a parenthesis somewhere, if I hit the wrong number, I can get messed up. So here's our backup plan. We're not sure. What's 4 to the second power? What's 4 squared? is 16. And then here, negative 3 times negative 2 is positive 6. And then I just do multiply. Okay. We did the exponent spell. So that's squares. Okay. So I did the exponents first, then I multiplied in the first part. So that's where the 96 is coming from. Then here, I look at this like it's negative 3 times negative 2. A negative times a negative is a positive. And when I get to that last step, now I can just add the 96 and the 6 together. And that's where the 102 comes from. I'm just simplifying. I'm plugging the numbers in for the variables, and I'm just simplifying it. Okay? And if there's a part that once we get through it, you're kind of like, maybe, maybe not, put like a little star next to a couple of those numbers, because I have a feeling over a little bit towards tomorrow, we're going to have some time to try some of these things and make them go a little bit quicker here. I'm looking like I lost a page. Is your next number when you flip over 23?
Yeah.
How did I lose a page? I'm going to have to find that middle page. All right, well, let's just go to 23 for now then. That's kind of interesting. All right. Simplify by adding like terms. So I can put together 4x and 8x squared and call it 12x to the third, right?
No.
No. Okay? These are different. Now, personally, but again, you don't have to do it in this order, I like to find the thing with the biggest exponent first and write that down. I don't see any other things that say x squared. I just write that one down. Then I look and I'm like, okay, what's next? So I see this has an x. Neither of these do. I just write that part down. But then, when I get to what's left over now, 7 and 3, those are just numbers. I can put those together. So what's 7 plus 3? 10. And I'm done. I can't go further. I can't make this like 22x to the third or something like that. I can only put together things that are alike, then I gotta leave it alone. Any order, as long as you have the same signs and the same things. Like if you had 10 plus 4x plus 8x squared, that's fine. And then 24 through 26 is the same idea. Look for the stuff that's alike, but watch your signs. Let's look at 5 plus 10. 5x. If I owed my friend $5 and I found 10 in my pocket, pay him back, I got 5. Negative 18 plus 9. That's a minus or negative 9. And that's, again, as far as I can go. What goes together in 25? Okay. So 1x squared, take 5 away. If there's no number in front of a variable, we always assume there's going to be a 1 there. I think somebody said it, but I missed. What do you got? Yeah. Negative 4x squared. And then again, watch your signs. What's 7 minus 3 going to be? 4y squared. Okay? That's where we're heading now. Okay, let me ask it in a little bit different of a way and see if this helps. What if instead of 3 square root of 13 minus 9 square root of 13, what if this was the question instead? Okay, it'd be negative 6x, right? I'm going to treat those square roots of 13 just like they're x's, just like they're variables. So, 3 minus 9 is negative 6. These are like terms. They're both square root of 13s. That's it. Okay? Were you okay when we were over here on this one? Okay? I'm just treating those square roots like they're variables. Yeah, the 3 minus 9 is the only part I'm changing. And then I'm leaving the square root alone. Just leave it as 13 under that square root. Yep. Correct. Then I wouldn't be able to combine them. That's a good question. Right. Okay. When you're doing these, well, my patience is getting together. So. Good question. I had a question asked, what if the numbers underneath were different? What if it was like 3 square root of 13 minus 9 square root of 17? Okay? In that case, I wouldn't be able to do anything. Because if the square roots aren't the same, that would be like having x and y here, and I can't put those together unless they're identical. So if these were different, I wouldn't be able to do anything. But since they're the same, that's the reason I can for that one. Yep. Yep. Okay. The other ones, basically, here's all I'm doing. I just start at the beginning and I find anything that has the same variable. If anything has variables. So like these both have an x. Sure, you can look at that like it's -5, sure. Yeah, you could do like -5 plus 10 here if you wanted to do that. Yeah, you don't have to look at it as 10 minus 5. You can look at it as a negative if that makes more sense. Okay, I was going to say, we'll come back, we'll hit some of those. So 27, find the perimeter. Now the perimeter just means add up the sides. And anytime I see those x's without a number in front, I just assume there's a 1 there. So I'm just going to combine the things that are alike. So all of these terms that have 1x, I'm going to put those together. So it looks like I got me 1, 2, 3, 4 of them. And then when I look at what's left, I have plain old numbers. 2 plus 3 plus 1 is 6. And I'm set. Again, that's kind of the concept that we're working here with. You notice all these things kind of keep me in the same thing. It's like 23, it was like terms, and then 24, 25, and 26 were different types of like terms. And now 27 is the exact same type of like terms. So bump up here a little bit. Still trying to figure out where that other page went. I have a feeling I'll find it by tomorrow. So simplify using the distributive property. When you distribute, remember, we're going to multiply. So we're multiplying -2 times each of those numbers. So what's -2 times 4 going to be? -8. -2 times -5. +10. Nicely done. So that's just going to be, are you paying close enough attention with signs? And as we get into 29, 30, and 31, it's the same idea. If I just see a negative sign, that's like having a -1. Basically, we're just changing signs. Negative times a positive is a negative. Negative times negative is a positive. And I don't, have anything that I can put together, so I just stop on that one. Yes. You could put a plus 1y. If you want to put a 1 in front of it, you could, but it's not necessary. 30 is the same idea. Negative 2 times 5 is negative 10. Don't lose your x. Yep. And negative 2 times negative 4 is positive 8y. And again, nothing is the same that I can combine, so I'm done. Now we'll throw the one twist at you. 31. You're like, ooh, fraction, yuck, I'm just going to skip this. If you see a fraction like 1/4, 1/3, 1/2, something like that, remember, all you have to do there is instead you're going to divide by this number instead. So I'm going to divide each of those by 4 if it's a fraction. So let's say divided by 4. 2. And 16 divided by 4 is 4. So keep life simple. Yeah, the 1 just, it wouldn't change anything. If I do 1 times 2, it would still be 2, or 1 times 4 is 2. You're just going to use the number on the bottom and divide by it. The fraction. What would be the first step in simplifying this expression? Okay, yeah, the 4 would have to distribute first. Okay, and that's all we got to do. I don't have to solve it. I just have to say, well, what's the first thing that I'm going to do here? Once we get that set. Let's do a few more here. I won't rack you till the very end. Let's do, let's see what we got left. Let's go to here, then we'll get stopped. Because I got to find that other page still for tomorrow. It's kind of weird. All right. Distributing with a little more juice. Thank you. Okay, this negative is going to change signs on both of these. Actually, I'm going to stop here. So, if the positive 8 becomes negative, then negative times negative is positive. This time, do I have anything alike that I can put together? The R. I got 3. I got 13 more. I don't have any other just plain old numbers, so I can write that down. 3 and 13 is 16. And the order doesn't matter. You could have 16R minus 8 as long as you get them both there. Same deal on 34. We've got lots of distributing to do at the start, and then we still got to find a way to combine all the terms. So let's see here. Negative 6x. What's negative 6 times positive 6? Okay, minus 36. And then we do the same thing in the second one. It's a positive 3 that we're multiplying. 3 times negative 2 is negative 6. Nicely done. Negative 6 plus 9 is 3x. Negative 36. Oh, my friend, $36. I borrowed 6 more. Now I owe 42. X's and Y's are different. I'm done. Okay, 35, last one we're doing today. Which one of the following here is a quotient? D, because quotient is divide, and a divide can look like a fraction. Tomorrow, don't be surprised if you come in if there's one sheet up there to find those missing numbers, and then we should be set. Yes?
Mr. Harty,